Okay, our next paper is by Andrew Gorin, and it's IoT Safety Predictive Monitoring of Lift Operations, Shafts and Buildings. Thank you, Andrew.
Good afternoon, everyone. I'm Andrew Gorin. I'm from Specialist Lift Services, and we specialise in designing and installing bespoke and non-standard lifts in the UK. And this paper has been put together as well by Professor Paolo Riva, who's in the audience, and I think will be able to help answer any technical questions that perhaps may get asked afterwards. So, where do I start this? Right, so dramatic slide. Buildings are vulnerable, more vulnerable than you might think. And I'm going to begin this presentation by setting the scene for why we've looked at this. More than 3/4 of the buildings in Europe are more than 25 years old. Over a third are over 60 years old. And as we all know, modern buildings, and I'd class 60 years old as modern, don't last like they used to. So the pressure on buildings and their structure is ever increasing, whether that be traffic volume or the height of buildings, construction methods, deep piling, roadworks, tunneling, or as of today, fracking. As you might have heard in the news, that's been given the green light by Jacob Rees-Mogg. So continual pressure on buildings more and more over the years as they go on. So the environment for building structural health out there is getting worse, not better. To add to this problem, a lot of the damage is invisible to the naked eye until it happens. No warning signs. Very hard to see without some fairly sophisticated monitoring equipment. Alongside that, we can see that lift accidents to the user are on the rise, and natural disasters are on the rise, and this is all having a compounding effect. So in the modern urban environment, that includes schools, offices, hotels, hospitals, people's home. The recent trend towards working from home caused by the COVID pandemic mean that more and more time is spent inside buildings. And as you can see, a stat from Australia's National Health Priority Area shows that getting on for 90% of people's time is spent inside buildings. This is also against the backdrop of ever-increasing urbanisation and of the anticipated global population of over 10 billion by 2050. Over 2/3 of the population are expected to live in urban areas in multi-storey buildings. So it's the backdrop over with, the scene has been set. There's a need to more accurately and more proactively monitor the health of buildings. And with the lift being the spine of the building, and with this lift shaft being a sort of protected environment, with only really the maintenance engineer ever going in there, what could be used using what if we could use the monitoring software and hardware from inside that lift shaft to not monitor only the lift shaft, but the overall building health? What we could combine the two. There are plenty of devices out there to monitor building drift and things like that, but they all tend to be fairly expensive. And in addition to this, who would find this information useful in addition to the likes of us, lift professionals in the room? You'd have insurers, urban planners. It would open up a whole range of possibilities. So how does this system work? It's a mixture of hardware and software. So the hardware are the physical sensors, one installed on top of the car, typically on top of the door gear, one sensor in the pit, and more on the guide rails, depending on the height of the shaft. These sensors are hardwired in, which is easy enough to do if you have shaft lighting in the shaft, which obviously most do now. And these sensors are relatively cheap, especially compared with more specialist building movement monitoring. Second thing is the gateway. So these sensors continually send data to the gateway, which is installed either in the motor room or somewhere in the shaft if it's an MRL. The gateway is connected to the cloud via GSM SIM cards to allow constant transfer of data, and huge amounts of data are transferred to that cloud. And then the clever bit, the algorithms and the machine learning are extracting various indicators and paint a picture of the lift health and the building health with ever increasing accuracy as the system learns from itself and from other gateways and begins to pull all that information together. So the algorithms themselves. These algorithms have been developed by Professor Paolo Riva and his team, and they're bespoke to this system. All of the data is based on vibrations and micro vibrations. So everything in this room, this phone, everything is vibrating a little bit. And if you can accurately measure all of that inside the shaft, what's going on, you've got a lot of data, and with the algorithm, you can start to paint a picture. And as I said, over the longer the period of time you've got, the more data set you get, and the more you can interpret. So the algorithms translate the data received into useful information and indicators. And then that is all pulled onto a dashboard to distill the information. And in a moment, we'll have a look at what that looks like. So then there's the cloud platform where the continuous stream of data is sent, the algorithms making sense of the data, and then the cloud running deeper analysis using cognitive computing and outputs being sent onwards to the dashboard. The dashboard itself, it's user-friendly. The type of data that can be adjusted for individual users. So if you've got lift professionals just interested in the lift bit, you've got maybe an insurer or someone else interested in the building bit, you can customize that. And it distills all the information and provides a proactive warning of potential future issues. It shows lift and building information. So what data is measured on the lift side of things? So you have the basic data such as number of trips, peak traffic, peak floors, energy consumption, acceleration, door cycles, door performance, such as time to close, vibration. Is one floor worse than another? Is one floor getting worse? And whether the lift's out of service. So the key thing, it builds a picture over time, and it can start to predict potential failures before they occur. So it's not perfect, it's not going to be able to predict everything, but as the example I just gave, if this is being monitored continuously and you can start to see a pattern deteriorating in a certain area, perhaps on the next maintenance visit, you're focusing on that, or perhaps it's failing quicker than that, and you need to go there as a non-breakdown visit. Also helps with intermittent fault diagnosis, as we used ourselves. We had an intermittent fault at the Hilton Hotel, Park Lane. Weren't really sure what was going on. We had this device fitted, and a report was pulled together from the data, and it allowed us to zero in, and then a technician was able to resolve it fairly quickly. And then on the building side, what's being measured there? So the system can measure at the moment building drift, building base acceleration, where people's disturbance thresholds are close to or are breached. So that's ISO 2631. And also no structure damage thresholds. So there hasn't been damage, but it's close to it. So ISO 4866. So as we said earlier, a much wider range of interests, or people potentially being interested in the data here than just lift professionals. And it's sort of an example of innovation in the lift sector that can potentially translate into wider industries. So that's the end of that. Try to rattle through it to keep us on track. If anyone has any questions, happy to answer them. And if they're of a technical nature, Paolo will do the business.